look like I've got anybody online right now, but let's get started on some stuff. Let's see. Last week I was working on Bit. I guess I'll work on Bit again this week. It's a fun little project we're working on. Did I have that open in here? I don't see it. Nope, there it is, right at the top. There we go. So now we have Git ready to go. We can set this over here. Looks like we had our table for code working. I wonder, where are we at here? Oh, I see, it's complaining about the indentation. Alright, so I'm not going to be modifying that at all. I was using Alembic to create the tables and such, create the migrations for the tables and all that, create all the SQL we need to create the tables, and that's also, these files right here are generated using Alembic based on where, oh, I have them right here. So like I have a model right here inside this bit file, just defines how it looks. I think the way I wanted to do this was I wanted to have like an audit log. So like someone would create a file, someone would delete a file, someone would edit a file, and all that information will go into its own table. So I'm going to need to track the bit that was edited. I'm going to need to track the bit that was modified, the bit that was changed, and then I need to track who did it, when they did it, and the type of action they took. So let's come back. I'm trying to think, because, trying to think how exactly. I don't want to get too crazy. Maybe we'll just track what action was taken, because I'm thinking we could like get crazy and we could keep a full history of everything that's going on. But I'm not sure. I feel like we'll just go simple for now. I don't need to keep a full history of stuff. Right, yeah, no, maybe. Code ID code. You know what's missing from here? A file name. Or actually, you know what? You know, that's what I might do. That's what I might do. I might actually, each bit will just be an ID and a user ID. Hello! How's it going, guys? Just working on getting the bit project working. It's going to be our little Discord servers. I guess it's not so little anymore. We're over 7,000 members now. But the Discord server, right now it's using GitHub Gists to host people's files that they upload to the server for security reasons. And that's on my personal GitHub account. And I want to kind of get those off of there. They're secret. Nobody can see them except if they have the link. But so what we're working on is coming up with our own little file hosting service where you can upload your code to there, and then you can share it on the Discord, or you can upload a file to the Discord and it'll automatically get uploaded to our little service, and then you'll get the link for it. So I'm just trying to figure out how I want to organize that and how I want to make that work. Last week I went ahead and I got everything set up so we can create tables in our database in a nice, convenient, easy to do way, and we can make changes to the database and we don't have to worry about writing any of that SQL. Alembic will do it for us. And so right now I'm just trying to work through in my head how I want to architect all of our tables and how I want to architect the data that we're using, that we're storing, so we can get all the information we want and all that. And like I think I want to track the history for each file, and I want to have the ability to have multiple files on a single page. Like you can do that with GitHub Gists, and I think it's handy for someone who like wants to show their like if you have like a web page, you'll have an HTML file, you'll have a JavaScript file, you'll have a CSS file, you might have like a backend file for like in Python or Java or something. So you could have like 3-4 files just for one problem, one question. So I think I want to support multiple files. And the way this is organized right now, you get your little bit, and it's going to have an ID, it's going to have the code, and it's going to have the user ID. But what I'm thinking I'm going to do is I'm going to change this so it's not just the code isn't on the bit itself. The code is going to go in its own little code table, and it'll just reference back to which bit it belongs to, and then it'll have a created date on the code, or a file name on the code. Yeah, we'll do a file name and a created date, and then the code that's being stored. And that will then point back to the bit it belongs to. So when you pull up your bit, I'm calling like each, like on GitHub it's a gist. For us, we're going to call it a bit. And what's going to happen is you're going to go to your bit, and it's going to check the database for all the code that belongs to that bit, and it's going to grab the most recent part of that code and show that on the bit. And this way we can keep history. So if you edit the code in the bit, it'll create a new entry in the code database, the code table, and then it'll use that instead of the older one. Hey, Kintech, how's it going? All right, so we're going to remove this. Well, actually, no, let me cut that. We're going to cut that and use it in the next table. Let's create a copy of this code. All right. No, I don't want to add that to the GitHub just yet. Okay, and this is going to be code. We're going to call that code. It's going to have an ID, which is going to be an integer. We're not going to have a user ID on this, but we are going to have a bit ID. So that's just going to be an integer, nullable, false. All right. So that's going to point back to our bit table. And then we're going to have the code. Whoops, wrong thing. It's going to be this right here. We're going to have the code. And then we need a created date. So that's going to be created. Yeah, just column. Did we import DateTime? There we go. I'm going to have to look up how to automate the creation of the created date. Move that down to there. We're going to do DateTime, nullable, false, server default, and then I think from SQLAlchemy.SQL import func, and then we're going to do func dot now. No, I can't remember off the top of my head. So let's just pull up Google real quick. SQLAlchemy default to current time. I've already looked this up, so like I vaguely know what I'm doing, what I'm looking for here. Func.now from SQLAlchemy SQL. So I imported it from the correct place. I'm not sure why it didn't show up. So I'll just go ahead and do that. .now. All right. So that should work. That should function the way we want it to. So we've got our ID, we've got the code block that's going to go in there. Oh, and we need the file name. That's what we're missing. Name equals column. We'll do Unicode, and then nullable equals false. And we're going to set that to be SQLAlchemy. I can't remember. I feel like this is parentheses and not square brackets, but I can't remember. Data types. Column and data types. Unicode. Where are you? There you are. Unicode. Fly down there. Yeah, it's a parentheses. So what we're going to do, because like the code, I don't really want to put a limit on that. Oh, I got the wrong thing up, don't I? I had been testing the lighting, making sure that was right, so I didn't have the correct thing up. There we go. There, now you can see what I'm doing. So we're going to go from Unicode. We're going to set a length on that. We're going to set that to 256. We'll just do that. That's how I'm going to make it. And I think I will put a limit on the code, but it's going to be a fairly decent limit. 2 to the 12, 4096. So we'll do 2 to the 13. We'll do 2 to the 14. That gives you plenty of characters. 16384. I don't know if there's a reason to go for a base 2 number. I just really like to do that. I don't know. It's just something I do. Alright, so now we have the ID, we have the code, we have the name, and then we have the BitID that this file belongs to. And you know, I'm going to rename this. I'm not going to call it code, I'm going to call it file. Alright, and then we're going to come over here and we're going to rename that. We're going to rename that to file. Okay, now we have our file model, and that will have the date time set on it in the created field. It's going to have the server default, which means that when the new column is added to the database on the server, database server, the database server will handle inserting the using the function now. So it'll put in the current time. So that'll be nice and neat and handy. So we won't ever have to worry about doing that. It'll always be UTC or whatever the database time is. All right. And like this is going to let us do a history, but in order to do that, do we need to do anything else? No, we don't. Okay. So what we're going to end up doing whenever we load up a bit is we're going to pull up the ID for the bit. We're going to have the ID for the bit. We're going to query a file table for all bits, bit IDs that match the bit that's being loaded. And then it's going to order them by created, and it's going to grab the most recently created for each of the names. All right, that makes sense, I think. Right? Yes? No? Maybe? You know what? We need to add one more field. Deleted. And the reason why is because if you rename the file, we want to delete the old file. Right? Yes? No? Maybe? Trying to think. Maybe we don't allow renaming the file. What we'll do, this is what we'll, whoops. Did not mean to do that. There we go. Bring that back over here. Get to the right spot. There we go. We're going to set the language of the file. And that's going to be a column, Unicode, and that I'm literally going to just do like 8. It's just going to be a code. Nullable false. So then it's not going to base the language of the code file on the name of the file. It's going to base it on the language setting there. Now, we will be able to... The problem is I'm having here is you can't change and rename the file because it's going by the name of the file. So it's going to grab the most recently created file by name for the bit, and it's going to show the most recently created one. So if you rename the file, now it's going to show the most recent one for the old file name and the most recent one for the new file name. So I'm trying to think if there's a way to make that work better. One way we could do that is you would have a file table. You're starting to get a lot of tables when you do this kind of stuff. One way we could fix that, instead of doing it this way, which I'm not even necessarily a fan of this because we can't rename the file, and that's what I'm worried about. One way we could do this is we have a file table, and then we do have a code table. And so like each bit gets a bunch of files on it, and then each file has code organized by date. And so then you get the history of the code. We wouldn't get a file name history, but I don't think that's necessarily a huge issue. We can put that in the audit log without any kind of problem. Yeah, I think we're going to end up doing that. This is going to go away again. And we're going to get rid of this. We'll base the language on the name of the file, And this, I'm going to cut this because I don't want that in here. So all this is doing, this is acting as like a bridge table for connecting a file to a bit. And then we're going to create a code table, which will have the code, the created date, and the file it belongs to. And then that will let us allow us to rename files, and it'll let us keep track of a file's edit history as well. Okay, so let's do that. So let me just copy this one again. Command-C, Command-V, code. I want to go back here because I want to get rid of all the extra stuff that I don't need anymore. And that is misnamed file. There we go. And then we come over here. We're in the bit model. Go away. This is the code model. All right. Code. And that gets an ID. This is going to get the code column, which is going to be 2 to the 14. There we go. And then BitID is we're going to do file ID. Like this should be a foreign column, but I'm not a foreign key. I'm not setting that up just yet. And then we need to put the date. We hit the right button here. Created. There we go. And that's going to get set in the database server. Okay, cool. All right. I think that makes sense. I think that works. So now when we go to a bit page, we're going to send in the ID. The ID is going to look up the files that belong to that bit inside our file table by the bit ID. And then it's going to go by this ID. It's going to query the code table for any code that has a file ID. And it's going to organize them by the created date and only grab the most recent files. The most recent code for those files. All right. Slowly but surely figuring this out. The next tricky part is going to be figuring out how to generate the next Alembic version. Alrighty. Okay. So we've got that. And I'm just like reviewing it to make sure everything looks like it makes sense. And we still have to create the users because on the bit it has user ID. So let's create the users. User, they get an ID. Trying to think, how do we authenticate them? I think for now, I think to start with, what's going to happen is I'm just going to rely on the bot to create stuff for the moment. So this right now, I'm just building a front end API that only fetches data. There's not going to be any create or edit logic. We're just future-proofing ourselves for the logic we want to build in the future. So we're going to have the Discord ID. So the user, we're going to have they're going to have an ID in our database, and then they're going to have their Discord ID. Is that even necessary? I don't think that's necessary. So we can make this the primary key. Primary key, true. And then just for speed, do I want to store their name? Because I can query the Discord API to get their name, but if I put their name in here, why? There we go. Column. What I'll do is we'll end up having a bot that monitors stuff, and we'll have it update the name or whatever. I think we'll have a few fields on this. So we're going to do Unicode. We're going to limit that to 256. Nullable false. Auto update. This will be if the bot sees like their username changes or anything like that. If this is set to true, it'll automatically update their username. If it's not set to true, it won't automatically update their username. Text. Is there a Boolean? There is a Boolean. Never mind. We'll use the Boolean. Boolean default equals true. Auto update mod equals column. Ooh, whoops. Boolean default false. Band false. Alright, so there, we have just a few little settings we can use. I might add, let's do an admin one. There we go. So we can just track some user information there. Come on, there we go. Let's go over here. We'll commit that. Remove code column from bit. Add user model. Add file model. And add code model. Now I do want to create an audit log. And this is where we're going to track things like file name changes, anything like that. Did we rename the user table? Yeah, we did. Cool. ID, user ID. Yeah, that works. We need this. When we need to import DateTime. And we need to import from alchemy.sql, import func. Right, like that. And then this is going to be, how am I in the bit file? All right, whatever. Go back to the way you were. Nope, not like that. There we go. We can get rid of that. Now we're in the code file, audit file. This is the file I meant to edit. Put my fingers in the right spot. That would really help. Alright, so now we're tracking user ID, when the action happened. Action, action, that works. Column, Unicode. I just want to use Unicode because that lets me do some fun stuff, like use emojis. Details, Unicode. Put that at the bottom. Okay, cool. So then you might have like an audit log for one of the users, and you have their user ID, and it's gonna be like file name change, and it's gonna tell you like, it'll like mention which bit the file was on, what the file name was changed to, and that'll let you just keep track of everything. The tricky part is, like, if we want to keep a proper audit log, we'll have to track like when the file was created, what the name was. Otherwise, you'll lose that. If you only keep track of what it was changed to. So like at the beginning, you'll want to create an audit, like file created with this name. And then it'll link out to, trying to think. Code ID equals column integer nullable true file ID integer. This is a better idea, right? Yes, no, maybe. Trying to think if we need to mention the code object or not. I don't think we need to mention the code object. We can do file ID. This way we can track what file got changed, if file got changed. And then we should have BitID. Do we want to? I'm trying to think. Yeah, 'cause someone might delete a bit. We might want to keep track of that, which makes me think maybe we want to come over here. Deleted. Archived. That's what we're going to call it. Archived column boolean default false. We need to import boolean. There we go. So we're going to make that. Add archive column bits. All right, close that. We're back here at the audit. An audit can point at a file ID, an audit can point at a bit ID, and it's going to have the user ID. You'll never have that be. Will that ever be? Trying to think if that'll ever be possible to not have a user ID set. I don't think the bot's ever going to be automating. Yeah, you would, because if the bot creates and upload a bit for somebody, no user did that. The user didn't create it themselves. So there's going to be no user in the process of creating all of the files and stuff. So in that case, the user ID would be null. So that's why that's going to happen. All right. Okay. And we do need to have this point at code. Because if you edit a file, you're going to want to know the code entity that was created, the new code entity, and you're going to want to know the file ID that it belonged to. So this just makes it a little bit easier to look up stuff real fast. It's a convenience thing. All right. Okay. So I'm trying to see if there's anything else. I think that's good for now. Come back over here. Add. Place my fingers in the wrong spot again. The audit model. Okay. So now we've got that. Now let's see if we can't figure out how we did the Alembic stuff. Over here, bit. Do we have it here? We're running something. That was the bot. Just trying to see what we have here. Unicode API reference. Alembic generate migration. There we go. Auto-generating migrations. Got that done. We got that. We just need the command here. log code file do we need to do poetry run? What are you talking about? Target database is not up to date. We're in the right spot. And I think, let's try this. I think I need to do this because I'm realizing stuff is not being imported. File user. Different error. Okay. Let's see if we can't figure out where it exploded. Inside of audit base column, it didn't like this, I think. SQLAlchemy default to current time. Did I miss something? Probably did. Yeah, there we go. It's supposed to be called. And then we have that same problem on the code file. It's really like this. So now if we run this. Oh, okay. Target database is not up to date. Okay, thanks for letting me know, I guess. So I guess it's time to Google that. Alembic. What does this mean? Let's try running that. Let's see what happens if we run that. I don't think we can come in here and see. Yeah, it didn't create a new version. So I'm a little bit confused. Poetry run. And then let's try running this. Okay, there we go. All right. Okay. And then we can do upgrade head. All right. So I think that worked. I think that one worked right there. All right. So we need to update the Git with the 2 changes we had to make. Fixed DateTime now default. Import models. And then generate new migration. There we go. All right. So now we have all the code we need to generate our database. We've got 2 versions in here. The 1 version. This is the new one. This one creates the audit table with all the columns. It creates the code table. It creates the file table. It creates a user table. And then on the bit table, you see it creates the archived column. So it adds a column, and then it drops a column, the code column, because we move that out into a table. All right, and then there's the downgrade step here, which is just, it re-adds that code column as a varchar, and then it removes the archive column, because that's new, and it drops the new tables that we just created. And then like we have the migration that we created last time, which just creates the bit table with the extra columns and whatever. All right. Okay, so what do we got to do next? So we've got all that working. This has all of our debugging working. Like, if anybody's got any questions, feel free to jump in and ask them. Like, it doesn't have to be about this code. It can be about anything. Like, if you're doing something and you'd like some answers about that, let me know. Like, that's what we're here for. We're just here to hang out. We're here to talk about code, ask questions, whatever's going on. Doesn't matter to me. I'm just writing code to keep the stream interesting, to show you guys my thought process, and so we can get some work done. Alright, I'm just checking the Discord server to see if anything interesting's happening there. Looks like Sinister has figured out how to get SSH working over the internet finally. I know they've been working on that for a few days now. Been a little bit tricky with their ISP. Alright, I see Kintech tagged me to let me know I wasn't sharing code. Why am I being tagged here? Alright, okay. Alright. I haven't read it. I've heard a lot about it. I know the Fluent Python book. I think it just got like a revision or an update or something. I know I've seen something about it on Twitter. I haven't read it though. I want to read it. I'm trying to think if I might actually have. I'm trying to see on my tablet here. Do I have? There we go. Just checking on my tablet. I think I might actually have it. I do have Fluent Python. I just haven't read it. Like, I haven't gotten to it. I started doing like tweeting through the grokking algorithms book, and then I've just gotten busy and been too distracted to continue going through that. That one's been pretty good so far. And then I have like implementing domain-driven design. That'll be an interesting book. Domain-driven design is kind of a complicated concept, and it's hard to like fully understand what they're talking about without actually like doing it. So I'm hoping if I get like the book, and then like I start like building some stuff with it, I'll start to understand domain-driven design a little bit more. So like the Fluent Python book, it's like on the back burner. Like eventually I'm gonna get to it. Eventually I'm gonna read it. But yeah, I know I've seen some stuff about it on Twitter, and I know it's a really good book. A lot of like the people who are really big in the Python community recommend it, which is why I have it. Like so many people have recommended it that I'm just like, I need to get this and eventually get to it. Eventually read it. I do better with audiobooks. I can just listen to them while I work on other stuff. But technical books and audiobooks don't necessarily go together all that well. Yeah. Yeah, let me know how it is. Like, because I'm definitely excited to read it. I have a lot of other stuff I want to get through first. There's so many books I want to finish, so many books I want to read. All right. Alrighty, where are we at? Let's see. Okay. So we've got the database working. Does that mean we want to move on? Because we've got the main working. So we've got the site file, which is where our server routes are at. Trying to see here. Like, I've got to figure out, because if we have a Discord bot that's going to be communicating with the web server, and uploading files, and then getting back the new bit address, we need a way to authenticate the bot with the API. So I'm trying to think how exactly I'm going to do that in a secure way that like someone couldn't like just hack it and get their own access. I could use like a JWT token. Maybe we'll mess with that. JWT is pretty fun. We could do some stuff with RSA. I've done it in the past. It's been a while, and I know the code I put up, I have it on my GitHub gist. The issue that I have is that when I last ran it, all the packages have been updated, and so it didn't run. It didn't work anymore. So I think that's what we're going to do now. We're going to need to create, well, maybe, I'm trying to think if we want to do that now, because it's not necessary. It's not necessary. We could just create the API endpoints, because like we need a list all bits, we need a, it's one too many lines, we need an API create, and then that's going to be based on, I mean, we could look at JWTs if we want. We could do that right now. Create bit. Let me just add this in here before I forget. Like, I'm gonna have to do a little bit of Googling for that, but that's okay. We can do that. That's not a problem. Create bit. Like I said, let me just finish this real quick. We'll do that. That will be a good placeholder. Let's create a Scratch file. New Scratch file, Python. There we go, Python. And then let's just look up Python create JWT. So we have a package pyjwt. It's basically what we're going to be doing here. Basically, all a JWT is a bit of JSON data that we are going to hash some information on it. Like, it's not like you're not going to get too crazy with it. Like the hashing, like everything is pretty much accessible inside of the JWT. The idea is that you're going to put data inside this JSON dictionary, this JSON mapping, okay? And then you're going to have, and it's just going to be B64 encoded. So it's going to look funky. Let me see. Do they have? Yeah, here's one right here. Let me make that bigger. So like right here, we have a JWT. This right here, this whole string right here, that's a JWT. And like each of these parts is B64 encoded. I'm pretty, if I remember correctly, they're just B64 encoded. B64 print base64.decode dot B64 decode B. So that's just like one section from the JWT. And then if we run this, yeah, see right there. Since she's B64 encoded, it's telling us it's a JWT. It's using the HS256 algorithm, which is like you see right here is what they're doing. They're telling it to use this algorithm. And then like if we decode the next bit, let's do that. This should be some more JSON data. There we go. And then that's just the data that they put in. That's the payload, the sum payload right there. So you're just putting that data in there, and it's getting B64 encoded. And then this last bit, this right here, this is the magic. If we don't hide our windows, I don't remember if this is B64 encoded. Yeah, that isn't B64 encoded. This is your encryption signature for the rest of the token. So, if anything changes in these two sections, when you check the signature of those two sections, it's not going to match this signature right here. So you're going to know the data has been modified. And that's the magic behind a JWT. The data is entirely public. Anybody can access it. You can send that data to a browser, and they can read that data, and they can verify the data is accurate. Yeah, exactly. It's kind of like a checksum, yeah. That's all it is. It's just using a format to pass in a checksum that over a JSON object. That's all that's happening. So you can verify that the data you're receiving is the data that was sent. That's all it's doing. And it's a really clever system. It lets you do a lot of really powerful stuff. And then using the B64 encoding, it's a little bit smaller, so you get a little bit of compression there. It's definitely a lot smaller than like using JSON, which can be a little bit. There's a lot of stuff going on. There's a lot of characters in there and taking up space. But yeah, it's nothing super fancy. It's pretty basic. The way I've done it in the past is using RSA. This is one. Let me try to see what you see here. So like you see, like they're doing the decode. So they're passing in. They have to pass in the same secret. So they have to know the same secret. The way I did it in the past was using RSA, so that you can literally have your token file, your RSA key, and that's what you use. You have your public and your private keys to verify stuff. So that there you're having your I'm trying to think what the word is. Is it asymmetric encryption? Asymmetric encryption uses mathematical. Yeah, that's your asymmetric encryption. So you're gonna have your public and your private key, and then you're gonna encode right here. We're encoding, and we're using our private key using RS-256, and then you're gonna decode using your public key with the RS-256. So there, that lets us. This is great because what this lets us do, and the reason why I was looking at using RSA in the past rather than using like HS-256 is because if I use HS-256, I have to store that secret securely on the client side. So like if I control both ends, if I control all the machines, that's not a big deal. But if I don't control the other end, like if I'm running a service in the cloud and I want you to be able to access that service securely, I don't want to give you the secret that you need to upload, because then if like anything goes wrong, like anybody could, if someone gets that secret, they could fake it. They could generate their own checksum. So if I use an RSA encryption, I have the secret, they have the public key. Anybody can take that public key. That can be put out into a GitHub repository. It can be put in the public. Anybody can have it. It doesn't matter. All it's being used is to verify that the data is the data that my service sent. So, since I have that secret key on my service, nobody can generate a signature for a JWT token from me. And that's why RSA is great. Because if you don't own both ends of the process, you can still securely do stuff. So, and like, this is a lot better than it was in the past. Back when I did it the first time, and I think this is why like it doesn't work anymore, is because like documentation like this didn't exist. Like I had to really mess around to get the RSA working, and so the documentation is way better now. And like you can literally see exactly how to do everything right here. And like these public and private keys, like if you've messed with SSH and you've done any of that kind of stuff, you've probably generated these keys before. So yeah, it's pretty simple. It's pretty straightforward. Like they've even got like their serialization, load a PEM private key. So they've got all that kind of stuff in there. I'm trying to see if there's anything else. Like there's a lot of neat things you can do with it. Like to just like it supports a lot of stuff, and that's what that first little section is all about. It's just sending that information of how was this JWT created. This way you know how to go about verifying it. And like you still have to know the secret. You have to know, you need to have that public key, whatever it is. And so like the difference, the technical name difference between using RSA, which would be your asymmetric encryption because you have a public and you have a private key. And then you have your symmetric encryption, which would be like this H256, where you have a secret. Where'd it go? They have their key. They're calling it a key here, the secret. And that would be your symmetric encryption because you have the same key on both ends of it. And it, like I said, if you don't own both ends of the process, this isn't going to be as secure because if anybody gets a hold of that secret, they'll be able to generate a JWT that is valid. And so that's the consideration there. That's where where the difference is. Now, if you've got like, I'll see you later, Miranda. So like if you have like multiple services in the cloud, you might not use RSA. You might just use H256 because all your services they're on your machines, you control them. If anybody gets access to them to steal the key, you have bigger problems. But like I said, if you have like an application that people install on their computer, you probably don't want to be giving out the secret. You probably want to be it's smarter to give them a public key and you have a private key that nobody else has access to, so they cannot create a JWT that looks like it came from you. So that's the consideration there. So I'm going to go ahead and like now that this is like I said, this is so much better than it was in the past. I'll literally just have to install PyJWT and we'll test it out in here, see if we can't encrypt some stuff. Poetry add PyJWT. Boom. And like you see how simple that is. Like if you're able to generate your own signature for the body of the token, you don't even need PyJWT. This is just a convenient little interface to being able to do all the steps for you. You just tell it what algorithm to use, you give it the key to encrypt with, and then you give it the data and it spits out the JWT. You could do all that on your own using your own cryptographic libraries and stuff. And like if we come over here and we look at our lock file, let's make that a little bit bigger. It's still a little bit small, kind of hard to see. But we're adding cryptography. We're adding the cryptography package by adding PyJWT. So like that's what it's using under the hood. So all you have to do is get the cryptography package, and you can do what PyJWT is doing all by yourself. It's such a simple, basic thing. It's just taking existing technologies and mashing them together to make something very flexible and very useful. Now, of course, you want to be careful because you're not actually getting encryption of the data. What you send in that token is public. So you don't want to be sending stuff just willy-nilly that you don't want just anybody getting access to. So like if you're using a JWT to manage user sessions on your website, you're going to want to be careful that you don't send something in the JWT that if it gets stolen is just going to give access to stuff that you don't want to have people getting access to. So there are some security considerations there. Is there a problem with the bot? Just saying that there might be a problem. Let me check. C#, boom, boom. Check this real quick. Interesting. Does appear that there is a problem with our Discord bot. See if I can't pull up. Did I get auto suggestions working on this? It appears I did. All right. Oh dear. Boom, boom, boom. I just tried and it didn't work. Oh, there it goes. Why did it not work on the first button press? I don't know. So let's go back. All right, so that's dealt with. Okay, where were we? We were just getting PyJWT installed, and I was showing how like it's just using cryptography under the hood, that's all it's doing. So now we can do from Py. We'll just do import PyJWT, or did they have it? Is it just import? What was the import for that? JWT. All right, JWT. And then we're going to have our data, something cool. And then we're going to have our, let's just be really simple up front. And we're going to do secret, the key equals super top secret. And then token equals JWT dot encode data, and then they just do key, and then we're using algorithm HS256, and then we can print out our token to check it out, and then we can do decoded equals JWT dot decode data key token key, and then algorithm. I don't think we need to provide the algorithm. It does want us. I feel like we shouldn't have to provide the algorithm, so let me just check and see if that's possible. The reason why I say that is because the first section tells you what algorithm is being used, so it should be possible to not provide the algorithm and get it to decode. It does require the algorithm. That seems a little silly to me. Why is it saying? Why is there a difference? Why is it algorithms versus algorithm? That seems a little bit odd to me, but there we go. There's our JWT token that we generated, and then there's the data decrypted from the token. So we got it working with HS256. Let's see if we can't generate a. Let's see if we can get it working with RSA. Generate RSA key. I'm going to generate new ones. I don't want to use my current keys. So I've got a few of them on hand, but yeah, all right. I see what we can do it that way. So we're just going to do a keygen, and we're going to do this one test key. We're going to put it right here. Secret. And then we can do cat test key. And since this is just, that's our private key. And then we can do cat test key dot pub. So like, and then there's our public key. So let me grab that. Public. All right. And then we're going to have private. Yeah, we gotta do it like this. So that's kind of big, but it fits. It works. Now we should be able to do was it RS? I think it was RS. Yeah, RS 256. And that 256 just means it's a 256-bit encryption. So it's really secure. And then we're going to do private. So we encode with our private key. And then we decode with our public key. And then we run that and something explodes. Do I have cryptography installed? I have cryptography installed. Right? Yes? No? Maybe not. Let's poetry add that. Poetry and cryptography. Let's get that installed. Apparently we don't. So that must have been saying that there was an optional installation in the lock file. All right, so maybe we need the new line. Could not deserialize. Or is it the... Do we need to get where? Maybe that's what we need to do. That might be it. So just gotta experiment here and see what we're missing. Interesting. Maybe, I don't know. Does this say... Begin open SSH. Alright, I see. Couple things. Begin, private key. And then down here, we're going to want to do end private key. Like that one looks like it's good to go. Still didn't work. Very interesting. What are we missing? Maybe, could it be so simple? Nope, it's not so simple. Yeah, so it's just a matter of playing around with it, seeing what we're missing here. This might be the issue. If we need a pass key in the private key object from cryptography. So let's just grab that. Private. And then we'll do key. Still didn't like us. So what are we missing? So let's see if we can't pull up Python cryptography, generate RSA key. All right, so let's do it this way. Let's get rid of all this junk right here. And then cryptography, RSA, generation. And then but how do we get the public key? Aha, there we go. So, private key, public key equals private key dot public key, right like that. There we go. And then we do private key dot, where is it? Public bytes. And then we have to do from cryptography import serialization. No? Where are we getting serialization from? Oh, okay, right here. There we go. Why are you complaining now? Okay, so that should be our public key. And then how do we get our private key? Probably the exact, a very similar way. Private. All right, and then we do all right, so then how do we, it told us how to pass the password in over here. That's in code. But how do we decode with the password? Interesting. Why are you like this? Serialization dot. Can we just pass it in like that? Isn't it missing one required pass? Ah! Why are you like this? From cryptography dot hazmat dot backends import default backend. We've already got serialization. Private equals serialization load. Private. Ta-da! There we go. All right, so we got it working. I would be curious if now that we've got that working this way, if maybe we could, instead of doing it this way, do it get rid of all that, and then with open. And what did we name those files? We named them test key and test key pub. Test key reading as private file. And then private equals, and let's read that as binary. Private file dot read. And then the public key trying to see if I can't load the file and make this work. Test key dot pub. Public file, public, load pem, public key. There we go. We don't need the password in that case. Whoops. How did we manage that? All right. Oh. Does it need me? It needs a backend and it needs data. All right, cool. Public, and then reload, and no such test key. Where are we running from? Import os os.set. Can I not set the current working directory? What we can do is, oh, that's what we can do. You know what we can do? We can do this. Import pathlib from pathlib. Import path dot. Just write like this. And then where are we? Projects bit. What are you talking about? Expand user. There we go. Yeah, so it doesn't like, for some reason, it's not liking the open SSH keys. So let's see if we just can't figure that out. Python cryptography, use open SSH key. That's annoying. So it doesn't support the current OpenSSH key format. That's why it's not working. Maybe. Or maybe we can load it using a different function. So instead of load PEM, load private SSL. Nope, I don't see that option here. In cryptography version 3.0, which version do I have? I have 37. What? So I feel like there's 35, 36. Yeah, 37 is the newest. So why am I not seeing the thing I need? From serialization, import load SSH private key. Like, I'm not blind here, right? Serialization, load SSH, public key. And this guy is saying private key right here. And he's saying in version 3.0, which is, if I jump over here, is there. And I am currently on 37. I'm currently on 37.02, which is the latest-ish version. What the heck? That's more. And like the docs literally say, so like let me just load SSH private. There's literally only one mention, and it's that one mention. What am I missing? Why is this not working? Why am I not seeing the thing that they're saying is supposed to be there? So like we're gonna do it. We're gonna do private key, load SSH private key, and then we're gonna load SSH public key, and we're gonna run it. And need bcrypt module. Yay! Alright. So we're getting somewhere. Poetry, add bcrypt. Now, bcrypt is pretty much the standard if you're trying to do like encryption for like hashing passwords and that kind of stuff. Let's try running that again. Read of closed file. What? Aha, I see. Public. Ta-da! Alright, we got it working. You needed bcrypt, you needed the latest version of cryptography, and apparently you need to use a function that does not show up in auto-completion. That is bizarre. Straight up bizarre. I don't know how that manages to function. If we jump into the serialization, SSH, there's public key, I don't know how. Where's the private key coming in? Because I see load SSH public key. Very strange. It's not even in the file. Yeah, there we go. So you can use your OpenSSH encryption keys if you want to. But you can also, like I did right here, you can literally generate the private key, and then if you want to write it out to a file, you just write this bit right here out to a file, and it'll create a file just like OpenSSH would. And you would do the same with your public key. You're literally creating the public key from your private key, and then you're just creating the bits, the actual bytes that would go into a file right here. And then you can literally write this out into a file, and you'll have your files just like you would with OpenSSH. So you've got a couple ways you can go about it. This is probably simpler to just use the built-in for cryptography, so you don't need to install bcrypt, and you don't have to use functions that appear to not exist, but that do somehow by magic. Like there's probably something in the cryptography package that is like monkey patching this into the module. I don't know how that's working exactly. It's odd. But yeah, so there's two different ways to do this RSA. One with OpenSSH and one with cryptography's own private public key generation. So it's not too hard to do. It's pretty simple, pretty straightforward. I'll probably actually, because like I find this stuff very interesting, so I'm probably going to put a quick blog post up about it, just like all the steps that we just worked through, learning how to do that, the whole process. So yeah. It's pretty fun, and like actually like being able to generate that stuff on the fly like this right from code is really handy, especially if you're going to have users that might want to have encrypted asymmetric encryption for authenticating with stuff. So like if you have like an API that you want to be able to access from an application or from like a package or something, you can generate those keys, distribute those keys to them, and then they can access your service. Like if you're doing like a platform as a service or software as a service kind of thing, API as a service, like anything like that, you can use this code right here to generate their own private key, and then you can literally have them set their own little secret on it right there. And then when you load that into the system, you use this code right here, and you just have them provide their secret key, and like all that stuff. Like everything is there. It's all right there. You can make it work. You can do all kinds of crazy stuff with it. The tricky bit is you got to remember you're working with binary, the actual bytes. So you got to read RB. You can't just read the raw characters, because things will come through. You'll get that Unicode encoding will start happening. Things will start getting wonky. Python tries to make that work smartly, so it may work sometimes, it may not work sometimes. It should work most of the time, I would think. Like if you like open up, like I did it before, I dumped it out. It's just normal characters, so for the most part it should just work if you do a normal read. They want it to be bytes. There's probably a reason for that, so you probably want to do RB for your read mode. All right. So like, how do we want to do this? So the way this will end up working is we're going to end up having a public key that's going to go inside of our bot code. And like, that's what's great here is I'll be able to literally just put that code, that public key into my repository for the bot. And I don't have to worry, because nobody can do anything bad with that key. All they can do with that key is verify that a JWT was signed by our Bit website. Alright, so how do we want to do that? I'm probably going to actually use OpenSSH just because that makes my life a little bit easier. I can generate maybe Does it really make my life easier? I don't think it does. Never mind. I'm trying to think through how I want to architect this so that we have, where do the keys come from? How are we generating the keys? Because I know how we're going to authenticate stuff. We're just going to pass that JWT in a header to our FastAPI. So let's see. Let's look at FastAPI authentication. In a hurry. I don't want to use OAuth. I don't want to use OpenID. Okay, so we have API keys. We can use a bearer token. There's OAuth 2, it can handle OAuth 2. And this would be if you've ever worked with an API before, this is going to be very similar to that. I think I'm going to end up using whatever this API key system is, and I'm going to set the token in the header. So the API key is just going to be a JWT token. And it's just going to contain information about the bot that's going to be using it. Now, how exactly? First steps. Let's jump over first step. How it looks. Password bearer, security. Where are we in this? Just trying to see if he's just doing it this way. Okay. So we can look at how that's working. Password bearer token URL equals token. What is happening here exactly? And this is what I don't understand. This is if you were on Sunday's stream and you were watching, you saw I was trying to use a form, just form data to upload information to my FastAPI, and it wouldn't work, and it wouldn't work, and it wouldn't work, and we were messing around with it. We spent 45 minutes working on that and trying to figure out why we couldn't submit a form to get it to do the thing. And then we realized we had to submit the data in the body as JSON, not as form data. And I could get it to work kind of with form data by installing Python multipart. And here we are. We're looking at this. This is the official docs for FastAPI. We're on FastAPI's website. We're in the docs for security. This is the example he has chosen to show for OAuth 2. Okay, that's everybody uses OAuth 2. And here we are to run it. First install Python multipart. Didn't mean to click that. Install Python multipart. This is because OAuth 2 uses form data for setting the username and password. Why isn't that just built in? I don't understand. I understand, it makes the install process a little bit easier. You don't have to install one more dependency if you don't need form data handling. But I just feel so much stuff already uses form data that kind of makes sense to just include it in the package. It just seems a little odd to me that it isn't included. And I can understand the argument for not including it. It's one less dependency that you have to install when you install FastAPI. And like, not everybody is going to use form data. Like, most people who work with REST APIs are going to use JSON data. And like, I understand that. But like, I feel like authentication and authentication is something most APIs are going to end up using at some point. And if your main example is going to tell you need to install multipart so that you can work with form data, because OAuth 2, which is the example you chose to include in your documentation, requires form data, maybe you should have just included form data. I don't know. It strikes me as odd. But whatever. Like, we can make it work. It's not that big of a deal. I do want to see if I can use API keys. Did I see something about... There it is. This is what I'm looking for. Password and hashing pair with JWT tokens. So he has something here for JWT tokens. So he's using Python Jose. Yeah, exactly. Like, that's for installing optionals, the optional dependencies. Yeah, exactly. It's a little odd. I don't understand it. And like, he's obviously like knows how to do that kind of stuff. Like, the person developing this is very experienced. He knows exactly what he's doing. So like, I trust him when he makes a decision like that. But it strikes me as a little bit odd. I'm not totally sure what's going on there. Now, I find it interesting. He's using Python Jose with cryptography for, I guess, JWTs to generate and verify the JWT tokens in Python. So that might be, I'm trying to look and see exactly how he's doing it. And then like he's using passlib for password hashes. I don't want to use password hashes. We're not using passwords. This isn't exactly what I want. This looks like, trying to see. Yeah, it looks like this is for storing passwords and stuff. I'm trying to see where his routes are. This is a lot of code. Wow. Token, getting a token, me items. So let's just see how he's doing this exactly. Where is crypt context coming from? It's coming from passlib. Okay. Pydantic, typing, FastAPI, security. So yeah, I think I'm going to be having to dig further. Where exactly are we in the docs? We're in the tutorial section. Advanced user guide. Just trying to figure out, because I want to use the API key, because I already know how I want this to work. So I just got to figure out how I want it's going to end up working. This is testing. He didn't have anything extra on security here. Deployment, generation, alternatives. Where are just like the general docs? Does he have... Huh. I was hoping to see if I could see like an actual like API documentation. I'm not seeing it on here. Oh wait, here. No, this is where we already were. I don't know why you had a link to yourself. Source code. Well, have a great night, Kintech. Thanks for joining me. Yeah, no problem. It's always fun talking about that kind of stuff. I'm thinking I'm gonna have to dig into this off stream because like it looks like I've got a lot of reading to do just to try to understand exactly how he's doing this. Because like in security, get current user. Security intro, like, is he linking to anything? What is this? Odd. I'm not sure. Maybe I've just got to play with it and dabble with it some. I'm not totally sure. Like, I'm looking at the docs, like this is startup guide, so it's not actually docs. I would love to see like actual docs just explaining, all right, here are the options you have. This is how you would implement an API key. Like, I don't know. It's odd. It's very strange. I don't know. Like here, I'm actually just curious what this is. How does this work? Yeah, this one looks like it works pretty much exactly the same as JWT. I'm interested, originally based heavily on the work of the folks over at JWT. So I'm curious what the difference is here. Why? I'm a little bit confused as to the logic behind this package. Oh, so this might be the reasoning. Okay, that makes sense. Yeah, this one looks to be very much tailored to work with Google App Engine. Alright, okay, so that makes sense. So I might use that instead. It's not a big difference. It's not a big deal. Yeah, interesting. I'm going to have to do some reading on how exactly to do FastAPI security and such. Like authentication, come up with a conclusion there. Because, like, I do want to allow people to authenticate with it. So it might make sense to try and think how I would want to do that. That's the question. And the way I do that might be tied to how I have the bot connect and authenticate. The difference is a bot isn't going to be a user on the service, so it's not going to have a user ID. Whereas users will have a user ID, obviously. So I have to do some experimenting, some reading, some testing, figure out some stuff. I think what I'm going to do right now is I'm going to call it a night on this. I've got some ideas what I need to be working on for the next time I dabble with this. We did get the database working. We got the new tables in place. We might have to add some changes in there, but with Alembic, that'll be simple enough because we might need to add changes that allow us to handle bot accounts and to handle user accounts and get the authentication down, get that working. Shouldn't be too complicated. Should be pretty easy. It's just a matter of I've got to figure out how FastAPI does it. And I'm not seeing anything concretely in the direction I want to go, just skimming through the available docs right now. So I might need to go read some blog posts and just like digest all that information. It's not super compelling content for a YouTube live, so I'm not going to plan on doing that tonight, but I'm going to write up a blog post on JWTs because I find that stuff super interesting. It's useful information, something I don't want to forget. So yeah, alright, it's been a good night. Y'all have a great day, great night, whatever time it is in your part of the world. So see y'all later.